Hi, fifth graders. Today we're going to look at two common types of decimal division word problems. So just like we looked at with decimal multiplication, a lot of times you see the same types of word problems come up with decimal division. So the first type of word problem you see a lot is when you're asked to find the better deal. This might be on prices at the store, it could be on who did something best or fastest, but finding the better deal is often a division problem because we need to compare the same amount of something. So let's look at an example. This example reads, Harlan drove 363 miles in 6 hours. Shanna drove 500 miles in 8 hours. Shanna said she drove faster than Harlan. Is she correct? Prove your thinking. So as I go line by line, I can look at each person more closely. The first sentence says Harlan drove 363 miles in 6 hours. The second sentence says Shanna drove 500 miles in 8 hours. I'm going to need to use division to find the speed or the miles per hour that each person drove because I can't compare 6 hours to 8 hours. Since it's not the same amount of time, I'll need to use a different way to tell which person drove faster. When it says Shanna said she drove faster than Harlan, that's how we know this is kind of like a better deal or a who did it best kind of question. And finally, I'll need to prove my thinking when I say whether or not she's correct. So for Harlan, I know he drove 363 miles in 6 hours. If I divide 363 by 6, that will tell me Harlan's speed in miles per hour. That means Harlan drove 60 and 5/10 miles per hour on his trip. Now for Shanna, she drove 500 miles in 8 hours. So when I divide 500 by 8, I get a speed of 62 and 5/10 miles per hour. Now I know exactly how fast each person drove, so I can compare the two speeds. Since 62 and 5/10 is greater than 60 and 5/10, yes, Shanna was correct. So you'll often see this kind of question, and this is also how this comes up in the real world. For example, when I'm at the grocery store and I'm looking at the value pack of goldfish versus just a regular pack of goldfish, I need to compare the same amount in both, even though both boxes might have different amounts of goldfish in them. So I have to use this idea in everyday life. Let's take a look at one more kind of question that you'll see. This is a question where you need to work backwards. So let's take a look at this one and then we'll digest it line by line. This question says, Carson spent $15.99 for 2 books and 3 pens. The books cost $4.95 each, and sales tax was $1.22. He also used a coupon for 50 cents off his purchase. If each pen had the same cost, how much did each pen cost? Okay, so this is one of those questions that seems really overwhelming at the beginning, but it's also a really good reason to go line by line. And what I'm going to do is as we go line by line, I'm going to set up an equation so I can get all the pieces of my puzzle in one straight line. So the first sentence says Carson spent $15.99 for 2 books and 3 pens. That tells me that he bought books and pens, and I also know the total. The total amount he spent was $15.99, and I know so far he's bought 2 books and 3 pens. At this point, I don't know how much any of that is worth, so I'm just putting the pictures in to hold the place. Now the next sentence says, the books cost $4.95 each. So that tells me since I have 2 books, that I can multiply $4.95 times 2, which gives me a total of $9.90. So I could replace these 2 books with the money amount, $9.90. That sentence also tells me that sales tax was $1.22. I know when I go shopping that sales tax gets added on. So I'm also going to add $1.22 in my equation. The next sentence reads, he also used a coupon for 50 cents off his purchase. Now I remember from the last chapter that we did that using coupons is often a signal to subtract. So that means when I was at the cash register and I put the books, the pens, and the sales tax together, when I handed the cashier my coupon, he would have subtracted that 50 cents off of the total bill. Now I have all the pieces of my puzzle, so I can work backwards to figure out if each pen had the same cost, how much one cost. So that means what I'm going to do is if building up from the left to the right means I add the books, I add the pens, I add the sales tax, and I subtract the coupon, when I work backwards, I need to do the opposite. So that means the first thing I need to do is I need to take that $15.99 and I need to add the coupon back in. That means before the coupon was scanned, the total bill was $16.49. So now I've used the coupon amount in my working backwards. I'll go to the sales tax. Since I would originally have to add the sales tax, when I work backwards, I have to undo that by doing the opposite. So now I'll take that $16.49 and I'll subtract the sales tax, which was $1.22. That tells me that my 2 books and my 3 pens cost $15.27. But remember, I figured out that the books cost $9.90. So in order to get the pens by themselves, I can take the $15.27 and subtract the cost of the books. So when I subtract $9.90, that tells me that the pens cost $5.37. We're almost there. Looking back at the story problem, the question sentence wants to know if each pen had the same cost, how much was each pen? Right now, $5.37 is the cost for 3. So the last step is when I take that $5.37 and divide it by 3, which tells me that each pen would have cost $1.79. So another common question is where you have to work backwards, and I suggest setting up some kind of an equation like this so that you can easily go backwards and undo each of the steps that you know to solve for the parts that you don't. Thanks for watching, and be on the lookout for these common types of decimal division word problems.